Good morning, everybody. Welcome to week 2 and happy Monday. We are going to get started now. And I hope you are all settling well and your first week, last week has gone fine. This is a time when you would see how the semester would look like for you, and I hope it's turning out well. So last week we did more like flew over, at a very high altitude, and so what the course is about, and had a little bit of discussion around different perspectives and things like that. If there is a metaphor I would use, we will land on the ground and be using something that we would need for a good portion of the semester. And we are going to be learning about R this week. And so it is going to be of a different thing. This is something that will set up for what is going to come for the first couple of weeks. And so the topic for this week is R, the programming language R. And I know most of you have joined and you are participating well in discussions we do. So I am going to start with a warm-up question for today as you all start to come. This is about programming language today, and a particular kind of programming language called R. It goes by the single name R. And I've had a few ways in which I could see your programming background, and the survey question which you have participated in asks you what you are proficient in. So I've got some idea. And I also have asked you about your background in this one. So to some degree, I know, as much as I can say I know you within a week, I know a little bit about your programming languages, what you speak, but I don't know anything about what human language you speak, and I'm curious. So today's warm-up question is, how many human language do you speak? And we can take a little bit of a generous definition, but I speak. If you speak fluent, perfect. If it's like halfway, you can make your way through a new city that you've gone to and you can pass by, that counts. So considering a little bit more than an average, how many programming languages do you speak? Is the question. I would assume everybody in the class speaks English, so the minimum number would be a 1, but you may have other numbers. So we are warm-up question. I know there are some who are just joining, so warm-up question for the day is, how many languages do you speak? I'm going to participate. Other times I let you say things, but I haven't. So I speak 4 languages. If you want to tell me what those languages are when you give me numbers, you can do that. You don't need to. I speak 4 languages, English and Norwegian being 2 of them, and 2 other Ethiopian languages are my other 2. And I consider myself fluent in English, but not in Norwegian, but a working one, just fine to get by. All right, so let's get started. And those of you who have not participated, the question for the day, the warm-up question is, how many languages do you speak? And I'm sure this class is going to be multilingual. All right, let's get started with this for today. And I'm going to, before I get, much like we do in other times, I would going to kind of points that I don't want to forget telling you. And so the first point I want to make is this week is going to be entirely about R. So I'll call it an R week. And we've got our 3 lecture meeting times, Monday, Wednesday, Friday, dedicated to discussions on R. And we have, in addition, the 2 tutorials that Helen will be leading on Tuesday and on Thursday that also will be about R. So it's all about R this week. And we have, in some ways, by adding these tutorials, added another 3 weeks to the program in a way. So this is outside our meeting times. And for those of you who need it, it will be an additional time, but it is also my kind of commitment to this course to make sure that we have what we need to have in the course of the semester. And this one is going to be one way to get it. Those who have indicated that you've got a little bit of background in R, you may benefit, but those of you who are new would absolutely benefit from having to go to those tutorials. So the 3 lectures we have on R will not be something that you would do things hands-on. And so make sure that the tutorials are used for those and additional things that you would do on your own. If there is anything that you know by having gone through one or another programming language, you would not get a whole lot of knowledge about that programming language unless you do something with yourself. So it's easy to get things explained, and you may browse through a book and so on, but the best way to learn about it is actually to do things. And so for that reason, there is also a good amount of things that you would do outside of the meeting times we would have Monday, Wednesday, Friday this week. Outside of the 2 tutorials that you would get, there is some document that I have put together and put it on Blackboard. So there was a question on chat where you have asked me whether this particular slides are not up yet. I would upload them right after class. But I have uploaded yesterday night what I have called our resources document. So, and I'm going to stop sharing this one and walk you through that one so you know what they contain and you would know why I have put them. One thing I would try to avoid is there is an overwhelming amount of information on everything, of course, but also around these things. And I don't want you to get lost. You will do a lot on your own. You would learn and you would make use of resources. But I also want to sometimes say, guard you against things that probably are not necessarily more accurate and things like that, but sometimes just becomes too much. And so this is also one way to help you as you teach yourself, learn yourself, and go through material, what would be a good use of your time. So I'm going to spend a little bit of time looking through that document that I have put together. Last week was about what data science is, what this course is about, walking through the syllabus, the course structure, and things like that. And the assignment is closely tied to it. And so it looked back at that. And normally, when I give you assignments, you'll get a week. You'll get a week to turn it in. But for this one, I gave you shorter time so that you would use this week for things that you have to pick up on R. First of all, let me remind you that the deadline for this one is Wednesday. I'm sure you will get to deliver on this one without much of a problem, but I have encouraged you to start early. And some of you have surprised me by how quickly you have done it. And those of you who have turned it in, you should know that I keep an eye on them and things like that, but I am impressed. And this looks like a class that is going to be fun and engaging to work with. With that assignment, there was one article some of you struggled to get on Blackboard. And I made that article. It has particularly to do with an image size that was a little too big for some browsers. And therefore, I have made that particular article on the course website. Those of you have asked me, I have responded to you. But the course website, which is public, has got a link somewhere that says resources. And if you go there now, or later, you would find out that those 2 articles are there. I hesitate to put things like that on the public website. The Blackboard one is what I would like usually to do, but on this particular case, I have put that one. So assignment 1 is due on Wednesday, and the article on which you are supposed to reflect on and answer some questions on, if you have not successfully got it through Blackboard, you should be able to get it through the course website. What you see on the right, this is a reminder for me. It's just a peek into what is happening with what we did last week. You can see this week is R. We are going to probably have a tutorial on Python, but it is not going to happen this week. So the survey indicates that there are some of you who have shown some interest in having something like that, but that will happen on week 3 or later. Otherwise, the topics that are lined up for the next 2 or 3 weeks are like this. But I wanted to put this third bullet point there, and this is partly because I got a couple of questions. I have talked about project and the importance of it, and we will have a lecture in which I would say here is what projects should look like, and ideas and things like that. And that my plan is to have some of these basic things out of the way first and have an overview of machine learning discussion before I give you the project ideas for this semester and invite you to suggest your own. But I have also told you that you are welcome to start thinking about projects right from the beginning. And so if you have that kind of preparation in mind, you are welcome to talk to me during office hours. And I have a couple students who have asked me about how to form teams. You really don't need to form teams right now. Some of you don't know each other all that well. Some of you don't have a good idea of what the project is. And sometimes it's better to wait until you see those things clearly to form teams. But if you have had friends and if you have worked on things that you know who would be partnered with, it's okay to think about that. So don't worry if you don't know that now and start to let's wait until that time comes when this will happen. All right, those were my reminders. And I want to stop sharing this one for a second. So I walk you through the R resources document that is posted on Blackboard. Anybody has got any questions on what I am have said so far? General questions? Okay, I'm going to stop sharing this and then start sharing another one for a second. Okay, I don't know which one you see. Do you see the resources document? That's what you see, right? Can somebody nod? Your hand. All right, I'm going to stop. Okay, I'm going to assume that you're seeing this. Okay, so the yes from Noor, I would assume that you're okay, and then I can see it here. So I have 3 groups, okay? The 3 groups are, the first one is a reference to a book. This is a book written by Hadley Wickham and a co-author, and it is called R for Data Science, and it is completely available online. There are a few chapters from that book that we will be using for especially the exploratory data analysis and data wrangling part, especially for data wrangling. And so that is one of the resources I would like you to have. This one is also linked from the course's website, from the public courses website. And we have to, it's good. It's a good book, and there is some things that we would do, but there are things that we don't need from that book. But I want to cite it as one example of a primary resource for this class. The second one is a group of sessions or a group of things that are done online. And some of you may this may work well for your timing and for the way you want to learn things. The first time I taught this course, we ran a tutorial, and Shira Brushat, who is a professor in computer science and teaches the Python course for those introductory people are not necessarily computer scientists take, she had helped with these additional tutorials that we are doing, like what Helen is running now, the first time I ran it. And what we ended up doing is she wrote the session as it went at that time and turned it into something that you could put it on a web page so that you can do it in an interactive fashion. So this is not a very structured way to learn about R, but it is an excellent material for those who have want to do in an interactive way. You want to open up your own thing and follow along, but it goes into some basic things, and it goes in a manner that progresses. And so those are they are called sessions because they are typed up, and they are things that you would see on an R session if you were to open a console with comments and exercises and things like that. And it walks you through, and you don't need a person. It is interactive, and there are comments on it, and they are publicly available. And so there is also a folder that she had made publicly available there on that same website where there are some data sets shared. So group number 1 was a book. We're going to come back to it and know it. Maybe you should bookmark it. And this one are 3 tutorial sessions that you can come to, and I would encourage you to do them. When you find out about them and you see what they are, you will, depending on your time and how much you need, you can pick and choose. But the first one is the one that would introduce you. The last one would go a little bit about into graphics type. The third group is probably one that, for those of you who are completely new, may find very useful. These are a set of videos. These are a set of videos that I collected from a Coursera course, or edX, I guess it was called, a few years ago, that Microsoft Data Camp did. This is for people who have no programming background, and it walks through things in a very simple way. And these sessions or these videos are made from the part of the course that is called Introduction to R. And then they had an intermediate one. And so this is not publicly available, and I don't want to make it publicly available on the course website, but on the Blackboard, it will be fine to do. So it has 7 modules. The first module you see here says basics. I'll come back to it, and then let me first show you. There is module 2, module 3, module 4, module 5, module 6, and module 7. Each one of them has got 1 or 2, 3 lectures. Each one of these lectures is about 5 minutes. And so you can see how much time this would make you do. No background needed. If you follow this string through without having to do anything before, you would learn a lot. We cannot have things like that going on. So these are great, great resources that you would use as you need. So the way these things are divided in topic is going to reflect some of the ways in which I'm going to do the presentation today. And so it has got topics that you would consider, very logical. So you have some of the basic types, the data types that you see, and there are things called vectors, matrices, which you would be introduced to today, factors and lists. This is how it goes. And the more complicated one called data frames comes at the end. And graphics, which is one of the fun parts about R, comes at the very end. These are videos. These are not mine. These are produced by DataCamp. Microsoft is involved in it. It is not publicly available, but at that time I had access to, and I have put them here, and don't make them anywhere else, but use them for your own. They are videos. You could watch them 5 minutes at a time whenever you get a chance. And once you know how they are organized, you will come back and see whatever it is that you need. But I want to warn you that this is meant for people who have no background, and therefore it walks you through. For some of you, it's a good news. For some of you, you may find it too simplistic. Some of you may prefer to a book and then read manuals and things like that. Okay, this was what I wanted to show you from this, and it is already available on Blackboard. Don't get overwhelmed. This is a good selection of things that will be useful, and something that you would, depending on your background, would need to spend less or more time on. So commit yourself to doing a lot of R this week so that you get the most out of the week and be ready for what is going to happen. We are going to also be using Python as needed as we go forward in the course, and then the few exercises in the beginning will be heavy on R. But if you choose to do things in Python all along on your own, you are welcome to do that also. But I have very good reasons why a skill around R is good for you. And so have the basic knowledge at least. All right, I'm going to stop sharing this one and come back to our slides. Share that instead. And we are, I think, good. Any questions on what I walked through now? And I have asked it if you see the slides the way you used to see them before, and if somebody can say, if at least one person can say yes, then I'll be very happy. Yay, good. Okay, I got a lot of it. Thank you, Brittany. Thank you, Noor. Thank you, Cody. So let me go now to what we are discussing. So let me be comfortable now, okay? So we are going to be talking about things that are best suited for having to do things on your own, right? They are not really material for slide type of discussions, but bear with me. And since you will be doing things on your own and you will be attending the tutorials, you will find this so this is, this discussion at a conceptual level useful on its own, but not going to replace these other ones. So about your question, I have not uploaded these slides today. I'm sorry, but I had reasons, but they will be available right after class. Okay, so they are not on Blackboard here. So why do I choose the R? Because this is a language that is designed for data. That's probably a good statement to make. And I think many people would agree. And here is a Venn diagram. Every time there is something, there is a Venn diagram, as I told you last time. And this is something that Helen found. I didn't actually. And she's trying to put you where you would fit into this picture. Don't get over concerned about the slides not being on Blackboard. Just follow me along. So statistical modeling, data visualization and manipulation, and R programming. These are the three things represented in this Venn diagram. And R analyst, the person who works with data and is using R for that purpose, would be a person that would be doing data science, and that's where you are. And so when I say it is a language designed for R, there are very many different ways in which you can interpret that, but it has to do with R being a statistical programming language to begin with. And it's not the first one. There are others, and there are many other things that make it attractive as a statistical computing language, but I'm going to spend a little bit of time on the next slide telling you the pros and cons of using R. But it is a language designed for R, and historically, it is an evolution that came after S, another language, by a single letter. Well, computer science languages are not unusual to have a single letter thing. C is one example. And of course, when we have other things, more things to it, we put plus plus to it. So there is S that is also a language, and that is what Bell Labs did in the 70s, I guess, or 60s. And there was some fundamental thinking about how the basic things should be organized under the hood for it to be effective in doing statistical computing. And R is an outgrowth of that. And so it was developed in a university in Australia. And the main idea behind it was to make it open source and public and useful for others. And then it became a very popular one. So that's how it started. One of the interesting features about it is it has got so very many libraries, and this will be a point that will be repeated again. The libraries are for data processing, data analysis, and many things. And it's being open source and free has made people to contribute. And so you have a huge resource to rely on, and you would begin to appreciate that once you start using it and see what it would mean when you have things that you can build on what others have done. It's an easy way to integrate those type of libraries into what you would do. And the fact that it has been done by a community that keeps on increasing in number would make things not to be done from scratch all the time. It has got data structures, and this will be a good portion of today's discussion, and what we will be discussing on Wednesday will focus on. And I've listed them here. It's not important for us right now on this slide to know what they are. We will unfold this as we go along, but it has got things that are structured to help take most advantage of data. Sometimes we run out of words. Data is one of them. Data structure for computer scientists is a very sacred word. You know what those means. And so you know how things are built up so that you have an efficient way to design your program, and design of data structures is a big topic there. The word data structure is used here is similar, but it is a little bit more general. And it is a little bit more general in the sense that you are now focused on data as we have tried to at least begin to say in this course. And so have a looser definition of what I mean by data structures here, but you have much of the structure of what traditional data structures are represented in what is listed here. We'll get to every single one of these in the course of the discussion today. When I asked you the survey question, I did not put it there. I used to have one question that says, are you familiar with MATLAB? Most engineering students would know MATLAB because it is one of the most commonly used high-level language. And so it will not require you to do programming at a level that the low-level programming language like C would do, but it is an extremely effective one, and it has got many things built around it, and people who have contributed, much like what I'm talking about are now in MATLAB. And the way in which things are operated in MATLAB and the way MATLAB is structured has got a very strong connection with linear algebra, how things are. Here it's different. And so the R idea, and you will see as I discuss more, has in fact one of the very basic decisions people have made when they first started to come up with it is to think of what would be the atomic unit, the thing that is the most fundamental thing that you would imagine, and you would need a way to abstract it, and that is a vector. So everything is a vector. It's just the dimension that changes. Even a scalar quantity like a number would be a vector. So the operations on R are extensions of those. And for that reason, R is big with bulk operations. So when you write a plus between two things, you are doing an element-wise operation. You will see, you will be familiar with this more and more, but I am kind of giving you an overview, a little bit of a random overview, but an overview of things and how it is different. So unlike what linear algebra will dictate us when we add two vectors or when we multiply two vectors, here everything is done in a bulk operation, which would increase efficiency, but it would also be a little bit more intuitive. And for that reason, I would associate this one with being designed for data. And as you see more examples, you would immediately say, oh, that makes sense because we need something like this. This would have to avoid for you to explicitly work through data structures by treating them element by element, programming wise, that is, but rather you have it in a single statement and it will take care of itself. And so many of the operations that happen on R are bulk operations. Before I get further, let me make two statements that you may find to contradict one another. On the one hand, R is designed for efficiency and for performance so that it would do things well. This is one example where you could say the way things are organized under the hood would make things run efficiently. This is when you are already accepting the fact that this is a high-level programming language. So you can say R is designed for efficiency in that sense, and you will be perfectly right. On the other hand, because it is a high-level programming language, performance as we know it, like myself, when you really, really care about running times and things like that, you would not want to start with a high-level programming language. You would want to do things on your own. You want to manipulate data, including how things are done in memory yourself, and that's how you get performance. For that reason, you could call an R piece of code that is written, not written in terms of performance in mind. And that's why you see large-scale machine learning and other things would very quickly go to Python. So R is designed for performance is a true statement when you think about the trade-off that you are having to be easier to work with and easier to be at a high level, but without making it slow, super slow and so useless. On the other hand, because it is a high-level language, compared to others that are at a lower level, or the ones that are designed more in terms of performance, especially runtime, then you can consider it as slow. All right. I hope you have gotten what I mean by this one. So let me give you a pros and cons slide. Much like everything else, there's always a plus and a minus to everything. And one of the things that you have asked yourself or your research has put you into, or question I have gotten from students is, should it be, if you are data science and in a serious way doing it, should you be working with R or should you be working with Python? There are other things that are coming up now, and these languages go up and down with each other. And there is more and more things that are started off with R that find their way into Python, and Python becomes more useful now. But one thing that you would most of the time find is you have a need for both. You have a need for both Python and R in particular in the context of doing things around data science and larger projects. And usually the first phases, the first things that you would need to do about your data and the thing that has to do with visualization is best done with R. And when it becomes product code or things like that, then people would switch to Python. That is not a bad rule of thumb to have, which is also another reason why you need to have both of them. But with that said, let me try to put the pros and cons, and both of them you see on the left and the right on this slide. One of the biggest advantages of R compared to other statistical computing languages is that it is free and it is open source. And that meant access, that meant also a large community, and that meant also something that would grow over time and support around it. Another big advantage with R is that it has an incredibly powerful way to do graphics. I don't think I have seen any other language that comes anywhere close to it, production quality-wise, but also things that would make it powerful to add things on a single one. And so you would, the second tutorial and the last or the second portion of these lectures would expose you to those things. Scripts are, for computer scientists, easy things, but for others, maybe not. So if you were doing MATLAB code, you would write a code at a time and in an interactive fashion, but that is on a session that you have opened, and then everything you have done will be lost. Instead, what you will do right from the beginning in your assignment, for example, the second one when it comes would be to write your piece of code into script, and then you can share them, and people would use them. This would increase reproducibility, among other things. And this is extremely important for people who are in the sciences, in different kinds of sciences. You have something that you produced, you have analyzed your data, you have your results, you publish your paper, but somebody else wants to do it, and so how would they do it? If you have scripts, then you can share with them, and they can get exactly what you got on their own platforms. And that is another advantage with this. Other statistical computing languages do not necessarily have that ability. The last point on the pros side here is directly related to the first point. The fact that it is open source and free made many people to contribute. Some of them are full-time people working with our related companies. Some of them are just enthusiasts and scientists who want to help others. And so what you have ended up seeing is there are a very large number of packages or libraries that they are called, and they are useful. And that will help the people productive in the sense that they don't have to start everything from scratch. Those were the advantages. I'm going to put two cons. One of them has to do with the nature of the language. It is easy to learn, at least the basics of it. We are going to get committed and learn a lot of R this week, and I can guarantee you, you would be able to get things accomplished, as you will demonstrate when you do assignment 2, for example. But it is a language that's actually challenging to master because it has got very many ways of doing the same thing, and sometimes some of them are a lot more efficient than others, and sometimes they could be confusing, or you know, it's easy to write bad code and easy to write things that may not work well, including have bugs. So it's easy to learn, but difficult to master. The other thing is it has made a compromise between being easy for people who do not necessarily have strong programming background. And so it has got also a chance for making some of the syntax for it to be a little confusing. A trivial example of it being designed for people who are not programmers is that, you know, indices start from 1 instead of 0. You know, those of you who have worked with C would know things would start with 0. This is not a big deal. Once you know what it is, so you can write where it starts, but it could at least be cited as one example of being confusing for programmers that have got some other background. All right, let me remind you now what I would have done if things were in person. I would have gone a lecture like this and say, for the tutorial, come with your laptops so that you get to install and things like that. Now things are all online and you have your laptops or whatever other machine you have with you all the time. That will not be necessary. So when it comes to the tutorial session, for those who will be attending, make sure that you go with your laptop. Make sure that you do these things ahead of time. And if you have issues, then Helen will help you with those. But I am going to make these slides available now. And so for those who do not have, the very first thing you, of course, need to do is install R. And it is because it's free, you will get to be able to do that. Sometimes, depending on what kind of machine you have, you may struggle for just a little bit on some of the things, but they should be all straightforward. There are two programming environments for R. One is the standard R, where you have a console and you would do things in a way that you probably are familiar with others. And the other one is called R Studio, which has got an integrated development environment, as it is called. And so you've got a nicer interface and some things that you could do to see data structure, how the file structure on your computer is and things like that. And so you could choose to have just the standard one or the R Studio one. And I encourage you to do the R Studio one. These are the places to go to get them. And so you pick installer of your platform and you follow the instructions there, and you should be able to do things without too much of a problem. What does the environment look like? One of the things that I have spoken about in the beginning, when I say that it is free and there are lots of packages that are written by people that you could take advantage of, those would come in one of two ways. One is that they are part of the standard R. So when you install it, you get it, and so you have it available. And the help that you would see there, and you will see these things when Helen runs the tutorial, or next time I open up something and you will see it for in your eyes, what it looks like, would be coming with R as standard. And so the package will be there and you will have plenty of them. Some of them, you will have to install them yourself. And so you would do this to install a package. Install the packages and then you give a name. In this case, this is a graphics package called ggplot2. And there are a few examples here what you would need. When we did this exercise last time, the warm-up question on take work born world, hello world was mentioned, one of them. So then, of course, there is a hello world always. And so there is that command that you see there. When you work, this is not meant to show you a complete list. So if you have successfully installed, you are in the environment, this is what you would see. And these are a couple of examples. When you have started working on an R session, you will have variables that are active in your environment. And just like you would do an LS to see what content you have on a particular directory, you can do that on your R session, on R Studio, or on the standard console. And when you see there, you can see the variables listed with this command ls. It will also allow you to directly view your current data structure. Otherwise, the environment, especially R Studio, is an IDE. Many people would, I think this is one of the best IDEs that they have worked with, and there are many reasons why you may say that. The ones that I have seen, I think, would be something I would agree with, that the R Studio integrated development environment is intuitive and is nice and has got a very nice user interface things. What it doesn't have, this is something Helen pointed out, and I'm not sure if you always need it, is it doesn't have autocorrection or autofill features. So whatever it is that you do will be on your own. Sometimes you might have seen some disadvantage when things are automatically completed. But for standard things, for those of you who write LaTeX, for example, and if you start typing something, there are some of these newer development environments where they would fill in the rest of the command, and that is very convenient. You don't see that, but otherwise, it's a very good IDE. All right, let me see how we're doing on time, and let me see if you have any questions. We've got 10 minutes. So I have, my goal today is to go through at least some of the basic data types and basic data structures, and have the more advanced ones and graphics on Wednesday, and we will wind up with R Markdown on Friday. So let me try to go through as quickly as I can with these ones, and the slides will be available. Just like every other programming language, in R, you will work with data of different types. The more common ones, the things that you would probably immediately try to imagine why they would be useful, are numeric types. And you've got two of them. You can have integers or double when you care about floating point operations. It's not very many times we care about floating point operations in this one. So the more common one is integer. So the one of the basic data types is numeric data types, and they could come in one of two forms. The other one is logical variables. These are variables that could have the value true or false. They're also called Boolean. That is supported by R. So we've got numerics, we've got logical, and we've got characters, things that are single characters or more longer words. In statistics, you probably have heard the word categorical variables. These are variables that would take one of many, but a fixed number of values. Days in a week, months in a year, that type of thing. And that is called a factor. And that is one of the data structures, but I included it in data type here. So these are there. And then a factor is a value from a fixed list, and we will work through it. So things that you know from other programming languages, and if you don't know any other programming language, you probably would not be taking this class, are there in R. There is a direct support for things that are about categorical values that you don't see in another programming language, and that is called factor. That is one of the new things. Don't worry about why I have written the way I have written this January, February. There's a C in front of it. That will be clearer in the next slide. The overview I want to give you now is, this was basic. This was, I've got one data type, and it is logical, it is a number, it is a factor. I have just one of them. Of course, you will always want to have a collection of them. You will very rarely work with single variables. If I want to compute the area, of a rectangle, I could work with just two basic data types, height and width, and so I can get a formula for having to do. Okay, so I don't know what the discussion was about. I think the screen is going fine. Me, at least from my end. Okay, but you will have things that are a collection of data. There are 4 collection type data structures in R. And you can group them into 2. One of the collection data types is of data types of the same kind. And the other is collection of data types of data of different types. The ones that are of the same type are called vectors. They're called vectors when they are 1-dimensional, and they are called metrics when they are 2-dimensional. Otherwise, they are the same data type. We'll spend a little bit of time talking about both of them. Vector and metrics is something that you are familiar with, mathematically speaking. So if you know what a vector would mean, at least in most programming languages, it goes the same way. It is a 1-dimensional data type, and a matrix has got 2 to 8 rows and columns. But what is common to both of these is that they are about the same data type. If I start with numeric things, I have numeric. If I start with Boolean things, I put Boolean everywhere. So every single element of a vector, every single element of a matrix is the same data type as every other element. The difference between the 2 is of dimension. You may find it surprising, especially if you're coming from computer science, for example, where you have programming language like C. You will not be able to have a data structure that would combine things of a different data type, but they are still one data structure. List in R is one of them. So you can have a list, and the list could contain types of different things. The first one is orange, the second one is person, the third one is a number, the fourth one is a house. You can have things like that. So when there are mixed data types, you have lists, just like a vector was a collection of the same data type, but it was on 1 dimension. List is a collection of things of different data type, but it is 1 dimension. When it is more than 2 dimensions, we call it a data frame. Data frame is one of the big advantages with R, and very R specific thing. That will be a subject for a discussion next week. So we've got this overview of collections we've got the basic data types, and we've got collections, and the collections are divided now in terms of dimension and data types. Homogeneous or the same type of data types, vectors and matrices. When they are mixed, we've got lists and data frames. So let's start with vectors. As I said, you would use these resources, learn the syntax of the language, and do exercises on your own. And so this will be more random examples and things that would very quickly help me get into a few syntax issues. One of them is how you create them. So you are going to work with the vector, and so one thing you would want to do is to create it. C is a keyword in R, and you will learn about things in R that are very unusual. So much of the function calls would be a single character like this. So key stands for create, and so you're creating now a vector of size 6, and it's got the values, and so you are creating it and assigning it to a variable called v. And I have used this symbol now, equal, which is one of the ways in which you do assignments, but there is another way you do assignments, the more standard way, and you will see that in a second. So here is how you create a vector of size 6, and you've got the values. And the values are started with indexing from 1. I've told you in the beginning that vector operations in R are bulk-wise. So if I had a vector created in this way, and say I say it's plus 6, the V was a vector. It had 6 elements in it. It was a dimension with 6, and the other number is just a scalar. Now I'm adding a number, and so what is going to happen? What will happen now in R is you are adding a 6 to every element in that vector. In that sense, it is convenient, and also the vector of the bulk operation that's happening here now is to add 6 to all values in V. You would not have done this one in C in this way, because that, first of all, the 2 would not add up because one is of a different data type than the other. But this one is interpreted by the language to mean that you have now decided to increase the value of every element of V by 6. If I do like this, now I have got 2 things that I'm adding, and both of them are vectors. And so R will figure out now you would want to be interested in adding the first element of the first vector with the first element of the second with the second, and so on. And so it doubles basically the elements in V. If I do this, now I have turned it into a Boolean. So the assignment that you see in the first 2 bullets I showed you is a less than symbol and a minus on it, that's an assignment, the assignment operator in R. I have used equal in the first slide, in the slide before this that I showed you. This is the way to do assignment. And this is R. I've not seen any other language where assignment is done in this way. What you see in the next one is just the usual symbol that we know, less than. And now you are comparing two things. And so the result of this will be a Boolean. And if this statement is true, it would return true. If this statement is false, it would return false. And because these two things are vectors now, and because vector operations in R are done bulk-wise, this would be interpreted to mean that you want to compare element by element, what's happening in V and what's happening in W. So you will get Boolean that is of the same dimension of these two vectors and would get values. So you get a Boolean vector comparing the values of V and W. Whenever the statement is true, you would get a true. And when that less than symbol is not true, then you would get a false. This is about subsetting. The videos that you will see when you go to that R resources will tell you how to access elements within a vector. So if I have a vector, if I want to get the first element, then I would go write the name of the vector, and then in parentheses, I would write the location. But I can also have more than one things are extracted out of that vector, and that is called subsetting. So in this case, I have the vector V, and I'm interested in looking at the first and the third. I have created another vector of it, the size 3, and so I'm getting the first and the third elements of that vector. That is what this notation would mean. You can also do Boolean operations within the things that you would specify. And so now I have a way to get to the vector, and I'm going to be interested in the places where the value is greater than 5. This one, I don't expect you to know because I haven't told you what which means, I haven't told you. But what the purpose of this bullet point right now is to show you, you can get a lot of things done in a single line. This is one of the places where you can write very compact nodes that could take you a little bit of a time to interpret it. But this is also a powerful thing because now we have, you don't have to write lots of lines of code to get something done. All right. And so what this one does is it returns elements of V that are greater than 5. That was vectors. Let me take you to matrices. Matrices are vectors that are of 2 dimensions. And so you've got rows and columns. And you will learn about this and do some exercises. But one thing that you would want to do when you have to do with metrics is to know how to create them. The function call, if you like, in R that would help you create a matrix is called matrix. Much like the vector was also called vector, and you could create it with the call for the functions called just C. For matrix, you would use the function called matrix, just in the ordinary word, the way the word is used. And then you can create matrices of dimensions of your choosing. You can specify how many rows and how many columns you'd like, or you can give how many entries you have and then specify either the row or the column, and R would figure out the rest. So the first example shows you how you can explicitly create a matrix with 2 rows and 3 columns. And the way to do it is by having n row and n column. These are parameters for the function called matrix, and the values are specified as 2 and 3. In the second example, you are creating a matrix. This time you are going to tell it what the contents are, and the contents of this matrix are going to be the numbers 1 to 6. That's what the first piece of that parameter tells you. The second piece tells you how many rows there are. So once it knows there are 6 entries to it and there is 2 rows, then R would figure out 3 columns are needed. And so that is a depiction of what the results would be. So the values 1 to 6 are added, and you get a matrix of that type. This is done because the values 1 to 6 now are added in a default way. R is called a column-oriented language. And this comes in distinction with MATLAB. So if I have entries and I am treating it as a matrix, and if I want to think of them as one continuous value, what R would do is have the values in the column first column first, and then go to the second column, and then go to the third column, and so on. You can change this one by saying you can want to do things row-wise. And so you could do that by having to specify that parameter called by row, and instead of having the values 1 to 6 entered by the conventional way, which is colon-oriented, you can force it to go row-wise, which is what the third bullet point here shows you. We are about 1 minute, so vectors and matrices is what we have covered. And so next lecture, we will start with lists and data frames. But this will be the way, the speed at which we'll go to when we are lectures, but whereas in the tutorials, you would get time to exercise yourself. All right, I'm going to stop here because it's getting close to 10. Let me see if there is anybody who's got questions. Immediately after class now, I'm going to post these slides on Blackboard and we'll continue on Wednesday, but you will get a chance to work with some of these on the tutorial on Tuesday with Helen. Anybody has got any quick questions for me? So there was a question about MATLAB and R. No, R is much more powerful than MATLAB. All right, I think if there aren't any more questions, I hope this worked out well for you, and I will see you on Wednesday. And if there is anything else that I forgot to mention now, I will make sure when I post this one, I will drop a note, post something on Blackboard. All right, I'll see you next time.